Recording now, this is lesson 1.2 on factors and arrays. Before watching the recording, please make sure that you have the following items. You need a graph sheet of paper, a pencil, a ruler, and different colored pens or pencils. If you need to pause the recording to grab those items, please go ahead and do so. Otherwise, I am going to continue. Now, anything that I'm writing down during the recording, you should be doing so on your page as well. And don't forget to pause or stop the recording and replay a certain part if you didn't quite get something. I encourage you to do that. Now, I'm going to continue. Please write down today's date. It may be different from the date that I'm writing down here, so please write down today's date. For me, right now, it is September 19th, 2016. Your title is 1.2, Factors and Arrays. Now, some of this may be review for you in previous years, but it's always helpful to revisit some useful vocabulary for this unit. Please use a ruler to underline your title as well. Now, let's start off with important vocabulary. Let's start off with factors. So, think to yourself before I jot down the definition of a factor, what is a factor? What operation is involved when you talk about a factor of a number? So think about that, and if you need to pause the recording again to think about it before you get the definition from me, please go ahead and do that. So, definition of a factor is a number multiplied by another number to get a product. Remember, a product is the answer to any multiplication question. Now, you can take a highlighter or a different colored pen. I'm going to take a highlighter here, and I'm going to highlight factor there because that's an important definition. Okay. So for your example, 2 factors of 24 would be 6 times 4, which equals 24, because 6 and 4 are factors of 24 because you multiply one by the other to get the product of 24. So we know that 6 is a factor, and you can do this in a different color, and 4 is a factor of 24. Another way of looking at it is that 24 is divisible by 4 and by 6. It's another way of looking at it because you're looking at the inverse operation. Okay, so that's our example. Now let's apply the definition of factor in a question. So, again, jot this down. I'm going back to black, which means you're in pencil on your page. So first question is, find the factors of 18. Now, you may have done this differently in previous years, but one method of doing it, and again, you don't have to do it this way, but I find this method makes sure that you get all the pairings and you tend not to miss any factors. So when you think of the factors of any number, you always start off with 1 and itself. Now, if you want to pause the recording again and just list the factors of 18 yourself, and then play the recording and see what I come up with and check it against your answer, please go ahead and do that. I'm going to continue though. I'm going to start off with 1 and 18. Now, I'm going to go up numerically from 1. I know that 18 is also divisible by 2, okay, because 18, if you look at it, it's an even number. I think of my times tables. 2 times what equals 18? 2 times 9. Now notice how I'm listing it. I'm listing it pretty far apart from each other, and I'm doing this for a reason that you'll see in a moment. And then I think numerically up from 2, I know that 3 is also a factor of 18 because it's 3 times 6 that are factors of 18. Now, this is where it's helpful to remember your multiplication tables as well if you can. Now, you know you've hit the middle when there are no more whole numbers in between 3 and 6, so you're finished. Now, this is where you take your different colored pencils and you pair them up. You know that 1 and 18 are factors of 18. I'm going to take a different color here. You know that 2 and 9 are factors of 18 and they're a pair. And then finally, you know that, I'll take red, 3 and 6 are factors of 18 because they are a pair. So again, this is what's called the rainbow method of finding the factors of a number. Okay, let's do another example. Okay, here's your second question. Let's say find the factors of, let's pick a slightly bigger number. Let's do, find the factors of 28. Okay, again, if you would like to pause the recording before I come up with the answer of the factors of 28, I encourage you to go ahead and do so. I am going to continue. Again, using the same method as above, listing 1 and 28 as the first factors, 1 in itself, right? Numerically up from 1, I know that 28 has 2 as a factor because it's an even number. And then I think, 2 times what equals 28? I know it's 2 times 14. Oops, 14. Now, 3 is not a factor of 28. Then I think 4 times what equals 28? It's 4 times 7. Now again, as in the previous example, if you know that you've hit the middle when there are no more whole numbers between 4 and 7, so you are finished. Again, you take your different colored pen and you pair up 1 and 28, 2 and 14, and 4 and 7. Oh, I should use a different color there. Sorry. Let's do red here. So 4 and 7. Now, here's another vocabulary word we're going to cover, and this has to do with factors as well, and also what has to do with multiplying. So perhaps you've come across the word array before. Now an array is, and again, think to yourself if you know what the definition of an array is. Perhaps jot down the definition or think of the definition before I give it to you. Now, an array is an arrangement of numbers in columns and rows. Okay, so again, an array, and I'm going to take my highlighter and highlight that definition. An array is an arrangement of numbers in columns and rows. Now, knowing that our example is going to go back to, let's actually go back to the arrays of 28. Now, the definition of arrays will make more sense to you when I tell you that one of the arrays of 28 would be 1 and 28. Okay, so this is an example of an arrangement of 28 in a 1 by 28. It would just be one row of 28. Now another flipped arrangement of this would be 28 by 1, but it would still be considered the same array. Another array of 28 would be 2 and 14. Okay, and another array of 28, you can probably guess what the final one is. It would be 4 by 7. So if you look at what an array is, it's talking about the pairs of factors. So think to yourself, how many arrays of 28 are there? There are actually 6 factors of 28, and I should jot that down here. There are 6 factors of 28. Now, therefore, if there are 6 factors of 28, how many arrays are there? there has to be 3 arrays of 28 because it's just dealing with the pairs of the factors, like its partners, as we paired up in the rainbow up there. Now, a question might ask you to sketch an array of a number. So say, for example, if I sketch the 4 by 7 array of 28, I would just use dots, or I would use X's, or I would use stars. You can be as simplistic as possible, but this shows how you understand the multiplying. So I'm going to do 4 rows of 7. So 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I'm going to use a different color here. So this means this is 7 dots, and these are 4 rows. So 4 times 7, that gives you 28. And that's your definition of arrays and factors.